So I prepared 2 exercises for today, and I was thinking maybe maybe I will talk about the question, the context of the question first, and then I'm gonna put you guys into breakout rooms, and you guys can work on it. And okay, so let's talk about the this particular context of question 1 first. Okay, so let's start. Okay, so question one, let's take a look. So what we're gonna do here is we're testing to see whether there's any effect of temperature on yield in a chemical process. There are 5 batches were produced at each of the 3 temperature levels. So we have 3 temperature levels: 50 degrees, 50 Celsius, 60 Celsius, and also 70 Celsius. We take 5 batches from each one of those. So that's going to be 5 multiplied by 3, that's 15. So I collected 15 observations and 5 from each one of those 3 batches. Okay, so let's take a look. The first thing before we go into the rest of the problem, I want you to take a look of the observation we have here. Is this a categorical data or is it numerical data, right? So that's typically the very first question I ask my students, also the question you guys want to ask yourself. Is this a numerical data or is it a categorical data? What do you think? This is an easy one, right? Everyone should be able to answer it if I call on anyone.
Numerical.
Numerical, great. Jackson and Benjamin, thank you. Okay, so this is numerical data. Okay, so if we are dealing with numerical data, we typically, usually, like 99% of the time, we are dealing with a mean problem. So we are dealing with a mean problem. We are not working on a proportion problem, not a percentage problem, a mean problem. So we are dealing with mu, and typically you may have X bar, you may have sigma, you may have S, right? Okay, those are the information we have. The next question I want to ask my students is, what is the number of populations here, right? What is the number of population? Does it look like a 3 here, right? Hopefully you agree with me. 3 populations, right? 3 populations. And I'm gonna ask you a trick question. Okay, a little bit tricky question. So what are the treatments and what are the factors? What are the treatments and what are the factors? So those are the terminologies we talk about in this module, right? What are the treatments? What are the factors?
Are the treatments 50, 60, and 70 degrees?
It looks like it's a 50 degrees Celsius, 60, and also 70. Would you agree with him? Yes, this is, yes, indeed correct, right? Okay, how about the factor?
Is the factor just the temperatures?
Yes, excellent. No one, Rachel is not tricked. Okay, this is excellent. So some other times students may think factors and treatments are equivalent or maybe exchangeable, but this is not. Treatments refer to the individual levels for the factor. So treatments, we have 3 different degrees, so maybe three different sets of temperatures. The factor is actually only one of them. There's only one factor here, one factor, and it refers to the temperature. Right, just some terminology I like to emphasize here. Great, excellent. And if you realize this is a numerical data mean problem, and the number of population is 3. So we would have to use ANOVA test. I like to write it out here. So this is gonna be ANOVA. So if it's ANOVA, that means we would have to carry out an F test, right? F test. Okay, so what we want to do next is, let's take a look. So we want to use ANOVA to test whether temperature level has an effect on the mean yield of the process. And we were also given the level of significance as 5%. So that means alpha is 0.05. Okay, so what I want you guys to do next is, I want you guys to try to fill in this, and feel free to stop at step 4. You can stop at step 4. If you do have time, you can check out step 5 as well. Maybe you can load the data from Canvas first for step 5. You can try it out first, but I'm gonna go over step 5 together. I'm gonna go over step 5 together. I want you guys to load the spreadsheet, which is posted on Canvas. maybe on your Excel, so we can work on this together. I think almost all of the groups were able to get an answer, and I'm sharing my answers with you. Okay, so let's take a look. So the first thing is you to write out a non-alternative. While I was in different rooms, I see that different students have a different habit of writing it. So it's okay to write it as a mu1 equal to mu2 equal to mu3. But it may be more relevant if you talk about 50, 60, and 70, because we were talking about temperatures, right? Okay. And I like to remind you, if you're not sure how to set up this, how to set up a non-alternative, you probably remember there was one meeting I told you there's a trick you can remember. So for the null, typically means no effect. No effect, whereas the alternative typically means there is an effect. So this rule, which I just explained, is very general. Hopefully it can be applied to a lot of different questions you have. Okay, so no effect here. It just means the temperature doesn't have any effect. If the temperature doesn't have any effect, that means mu 50, that means the average yield on this chemical process under 50 degrees is going to be the same as the average yield under 60 degrees, and it's going to be the same as that under 70 degrees, right? If alternative means there's an effect, that means there's an effect coming from this temperature level. That means not all mu's are equal. I like to remind you guys again. So when I say not all of them are equal, it doesn't mean all of them have to be different. It doesn't mean that. If you have two of them to be the same and the last one is different, that's going to fall into the alternative. It's going to work for the alternative. You don't need all of them to be different. You just need at least two are different. You know, regardless of whether the rest are the same or different, it's all fine. And so I want to, you know, some students were having difficulty to look up this p-value, and I like to do it again if you don't mind. So I put up, this is my F table here. One thing I want to remind you guys is, okay, so there are several things that's slightly special about F distribution. F distribution, again, it is not symmetric at zero. It's not a symmetric at zero. It's very much like the chi-square we talked about last time. So, okay, so let's take a look. So this is the chi-square we have. You probably remember, and I left my notes there. So chi-square, it actually says if your test statistic, if the chi-square test statistic is close to zero, close to zero, it means there's a lot of support to. There's a lot of evidence to support a null, so you will fail to reject a null. If it's very far away from zero, that means you have a lot of evidence to reject the null, right? Okay, questions from you guys? And so I'm gonna go to the F table we have here. They follow the same kind of a pattern, right? Same kind of a pattern. So if you're very close to zero, what you're gonna do is you're gonna fail to reject null. If you are very far away, for example, a huge positive number, 20, 500, you are going to reject the null, right? Okay, so it is symmetric. Another thing you want to realize is there are the numerator degrees of freedom, there's a denominator degrees of freedom. So in our example, we have is a 2 versus 14. That's the degrees of freedom we have. And I want to look up the numerator, which is 2. I'm going to go down this table like what we did here. So I'm going to go down it until I reach the denominator is 14. So denominator 14 is right here. 2, I think, is right here. So what I want to do is I want to focus on those numbers here. So all of the numbers given here, they represent F ratio. And the numbers on the left, the numbers on the left represents the upper tailed probability, Okay, so our test statistic, I think, is a 1.78. So that's right here. You can see 1.78. 1.78 is smaller than 2.73, and you have this 10% here. So I'm going to draw a small F distribution here for illustration. Okay, so let's try. So this is a F distribution. Okay, so this is F214 we have here, and this is 0 right here. Okay, so what we know here is 2.73 has an upper tail of a 10%. So 2.73 is gonna be, say, right here, 2.73. Okay, upper tail is 10%. Okay, what do we have here for our particular example? Our particular example is 1.78, right? You see it, 1.78. It's gonna be somewhere in between. This is only for illustration purpose, so it's not drawn to scale. So 1.78, now we have to figure out what is the p-value here. So p-value for both chi-square and f-table, the p-value is always upper tailed probability. P-value is always upper tail. Okay, so I'm gonna write down here. I've already explained that for chi-square. So you focus on the upper tail. So p-value for our 1.78 is gonna be this part. Because we know this one right here is 10% and the blue area is definitely more than 10%. So from this table, we know that the corresponding p-value for 1.78 has to be more than 10%. So this one is more than 10%, right? So the p-value is more than 10%. And now, as you can see, right here is 10%. Right, okay. And the conclusion is p-value is greater than alpha, so we fail to reject, and we can conclude temperature does not have an effect on the mean yield. So that means, okay, so that means from this data, the average of those three look pretty much the same. They are not different, pretty much the same. Okay, any questions from you guys? Maybe I should go to this one. Maybe some of you were copying some of the words. Okay, if there's no questions, I'm gonna show you how we can carry out the same procedure using XLSTAT. And so maybe you have already tried it with me as well, right? Okay, any questions from you guys? There's no questions, so let's take a look. So for step 5, what we want to do is we want to check to see whether we are able to obtain the same ANOVA table using XLSTAT. And data is loaded. Data can be found on Canvas, and this is the comments we're going to use, right? I'm going to show you how this can be done. Okay. So what we want to do is we want to use XLSTAT to carry out this same procedure. Okay. So if you have already loaded data, you probably are able to see there are 2 different data formats here, right? Okay, the reason I have them here is because I want to show you what different formats mean, and this is going to be critical when we try to use XLSTAT for this ANOVA test. Okay, so they are the same data sets, but they are presented in 2 different ways. The first one is the data format that we've seen given in the question itself. We have 3 columns here, 50 degrees, 5 badges here, and 60 degrees as well. I'm going to zoom in a little bit, maybe. Okay. Is it too small for you guys to see, or is it just nice? Are you able to see well?
Yeah, it looks good.
Okay, good, thank you. And okay, so 3 columns here, 50 degrees, 60, and 70. And also I included one column here for observation. And if you only use those 3 columns as what we have seen in the question, you will not able to get a correct answer. I mean, there are sometimes some problems with XLSTAT. So I have to include this additional column, which says observation 1, 2, 3, 4, 5. Okay. The first kind of a data format is called table format. And it just presented in a table format. Each column represents 1 different treatment levels, right? Okay. So what we have next is the same data being presented in a column format. Over here, we have only 2 columns. So the first column represents the yield we have. There are 15 observations. And the second column represents the different treatments they are receiving. Each treatment, each row received. For example, the very first one, 34. So this 34 comes from 50 degrees. So I put 50 here. And the very last observation, which is 31, that actually receiving 70 degrees, so I'm going to put in 70 here. So I'm going to ask you one more question. Do you think the 50, 60, and 70 here, are they quantitative variables or they are qualitative variables? Or in other words, are they numerical or are they categorical? Are these 50, 60, 70? Are they numerical or they are categorical? Okay, so I guess no one has answered yet, but let's try to use XLSTAT. So first is you go to XLSTAT. I think you are going to click on modeling data, which is right here. Hopefully you are doing it with me as well. Click on modeling data. We are running ANOVA. So that's going to be here, ANOVA, right? I'm going to click on ANOVA. And we're going to get a dialog box. So this is the box I have. The very first thing I like to do is I like to reset it. So reset. Okay, so everything is back to the default setting. I'm going to try it out in different ways. So the first thing I'm going to do is I'm going to try it out as a column, data format is column. So this is the column format which is referring to. And you were asked, what is the dependent variable? And it has to be quantitative. This is nothing but our yield, right? This is our yield. So I'm going to just write it down here. It's going to be this one. I'm going to highlight this. Okay. The next one we have is you were asked what the x is, which is exponential variable. You try to use the temperature to explain their different yields, right? This is what we're going to do. Okay, so you were asked, is your temperature quantitative? That means it's a numerical, or is your temperature qualitative? That means it's a categorical. What do you think? Is it quantitative or is it qualitative?
Qualitative?
It is qualitative. Even though 50, 60, 70, it looks like it's, numbers, but the problem is you want to think about it, they are considered 3 different groups, right? There are 3 different groups. So we're going to consider them as a qualitative. Excellent. Right? Okay. And we do have variable labels. Make sure you check that. We don't have observation labels. And I'm going to go to options. I think options, everything looks fine, and you don't have to do anything for here. Validation, you typically leave out the validation. We are not doing any prediction. Do we have missing data? Yes.
I was just curious, do you have to highlight yield and temperature? Do you have to highlight those titles, or can you just do the raw numbers?
Okay, you could do the raw number. If you do that, make sure you uncheck the variable labels, right?
Okay, thank you.
Okay, I would recommend you to use the yield and temperature. The reason is because once XLSTAT spits out some output, they are going to make reference to the yield and temperature as well. Otherwise, they are going to talk about column G, which may not necessarily make much sense to us. I mean, we could also go back to the spreadsheet, but it's more intuitive to have yield and temperature marked as well. Good. Excellent question. Excellent. Any other questions from you guys? Okay. If not, let's see. I'm going to go to the missing data. We don't have any of those outputs. And I don't think any of those are relevant. You can leave them. That's okay. I'm just like, prefer fewer outputs for me to worry about. So the key is to make sure you have ANOVA checked, right? Okay. So means this is all fine. You don't have to do much thing. So there are XLSTAT gives much more sophisticated. You have a wider range of variety of tests they can do for us. But so far, we're doing the simplest thing. So you can leave ANOVA checked. Everything else, you don't have to worry about. Okay, I'm going to click on OK. And you're probably going to see XLSTAT is running. Okay. And what I'm going to do is the very first thing I like to do is I like to remove all the grid lines. So I like to click on this one. So it's going to make the presentation much cleaner, as you can see. And if you click on here, you can see different outputs for what we have. Okay. And you can also go down. That's going to show you individual outputs as well. For example, we know that we are focused on ANOVA. So I can just click on this one. And that's going to take me to ANOVA right away, right? So this is neat. Okay. So let's take an ANOVA table. And hopefully you guys actually see that you should have 1.78, just like what we did before, right? So that means we did the right thing. We did the right work when we try to set up an ANOVA table by hand. And as far as p-value is concerned, we use F table. We know that it's going to be more than 10%, but we don't know the exact p-value. XLSTAT is a software, is able to calculate the exact p-value for us. And it told us it's 21%, which is indeed more than 10%. So that means our calculation, again, it is correct. It's 21%. Okay, and there's a lot more other information being provided. For example, here, this is what we're gonna use next week, and I'm gonna spend more time to talk about it. And other than that, I think you probably don't need much other information here. Sometimes XLSTAT also gives you nice graphs. Okay, so let's take a look. So for example, the very last plot, it shows the yield for 50 degrees is higher than the yield for 60, which is also higher than 70. So it looks like it's higher, but after carrying out a ANOVA test, we know even though there's a little bit difference, but the difference is not statistically significant. There is some kind of a difference going on. 50 is higher than 60, which is also higher than 70. But the difference is not statistically significant because we were not able to reject the null, right? That's the key we try to set out this test. A little bit difference is not enough. We need a huge difference to declare there's a significant difference, right? And that's why we just set up the F table, look up the F table, or maybe use XLSTAT to check the p-value, right? Okay, and so now what I'm gonna do, any questions on this part when we try to set up the analysis using column format? Okay, if not, I'm gonna show you how this can be done on table format. It's pretty much the same, modeling data, ANOVA. Okay, so I'm gonna reset everything. Okay, and I'm gonna choose table format here. If you do choose table format, if we only, for example, if we only have those 3 columns, just say we don't have the first column. Okay, I'm gonna choose number of factors, which is 1, right? Temperature is the only factor we have. And everything else, you can leave them as default. If you do click on OK, XLSTAT is still gonna run for you, but there is gonna be a problem. Why do I say that? Okay, so I got an output from XLSTAT. I'm gonna remove all the grid lines. Okay, because I see there's a problem. It says the number of observations is 10, which is not correct. We have 15 observations, remember? And XLSTAT thought there's only 10, so there's a problem here. And as you can see, okay, I'm gonna go to the ANOVA table. You probably realize the degrees of freedom should be 15 minus 1, which should be 14, but we have 9 here. So there's a problem. Okay, we're gonna fix that problem by go to the very top. I'm gonna click on this red triangle here. Okay, I'm gonna click on this one. It's gonna take me back to the same dialog box we had here. And now I'm gonna do a little bit modification. Instead of choosing this one, what I'm gonna do is I'm gonna choose the first 4 columns, as you can see, all right? I created this column here. I'm gonna click OK. It's gonna run again. And as you can see, the different results are given under different tabs. I'm gonna disable all the grid lines. Again, you're able to see the number of observations is 15. This is correct. If you go to ANOVA, you can see everything is the same, right? Now this is the correct one. And you can copy this table into your Word document. Maybe when you are working on a project, you can copy it into your project, right?